This is my all-time favorite type of modification. This is the amazing Snapmaker U1 working together with the Anycubic Ace Pro. This is a filament management system with heating available. It is enclosed, and this modification allows us to remove the spools and the motors from the side of our U1, making it nice and neat, and gives us the ability to put our filament inside of a box that can dry and heat and manage our spools. And what I mean by that is this doesn't actually add FIRMWARE spools to a single tool head or anything like that. What this does is, instead of using the motors on the side, it's using the motors inside of the Ace Pro. So it gives us essentially a single spool for every single channel, every single tool head on this machine. This is essentially a third-party firmware working on the U1 and a third-party set of config files working on the Ace Pro. Since both of these things run Clipper and are now kind of open, you can now combine these two things into something like this. So there's two projects going on here, and a huge respectful thank you to Dimitri and Artyom for doing all the heavy lifting. All of the files and everything from them is going to be linked down below. I'm just here to show you how cool this is. This type of match right here just would not be possible without the open source community, and that's why I really love this type of stuff specifically. But yeah, there's lots of benefits here, but there is some downsides. For example, this machine is known for printing TPU really well because there isn't much obstruction from the side spools. However, as we all know, the Ace Pro is not very good at TPU. In fact, I wouldn't even put TPU in there. So for example, if you print a lot of TPUs, this isn't going to do you any good, and you're going to have to put on one of your stock spool holders on the side and bypass the Ace Pro if you're going to be printing some TPU. No big deal, but worth knowing. The other thing that you need to know is, in order to do this modification, you're going to need to either solder 3 small connections or crimp your own wire and cut up the standard wire that comes with your machine. I advise against that, because if you solder on a female USB connector, you can use the Ace Pro with any single Clipper machine, which means if I wanted to add this to my Voron or anything else with Clipper, I could just do that with a USB-C cable. So once this thing is modified and has a female USB-C, which I'll show you how to do, it's actually really easy, well, then you're going to have a really cool thing that doesn't even have to just stay with the U1. You can use this with everything else, and that is so cool. Then the firmware on the Snapmaker gives us a bunch of other things, like for example, within Fluid or Mainsail, you can now see the camera in full resolution. There's also a bunch of other tweaks you can do to the machine if you wanted to. You don't need to or have to whatsoever, but it does give us a lot more power. There's also settings in there to make the machine a little bit more quiet. We'll go over all that kind of stuff, and I'll show you what that's like. There's a really easy configuration kind of GUI instead of manually putting things in. But yeah, I think this is a phenomenal thing, because now I can have my PETG in here, I can have ABS in here for when the cover gets here, and I can go ahead and heat this thing or preheat my filament or dry it, whatever, right in here and manage it instead of it all hanging on the side of this machine. All right, here's what we're going to need. We're going to need a soldering iron, a female USB-C cable, which I'll link down below where you can buy one, or you can cut up your own USB-C cable. You can even cut up a USB-A cable, because that's how this is going to be hooking up here. You're also going to need a USB-A flash drive so that you can get some files on to the printer, which is how we're going to be flashing the firmware onto it. With that, you're going to also need a computer with a couple programs. I'm going to be doing this on a Mac, which you'll see in a second, but there's obviously ways that you can do this on Windows. There's going to be instructions for all this in the official GitHub repos for each one of these things, but I'm trying to make it easy so you can follow along and just do it as easy as I did. All right, let's go to the table so I can show you how some of this stuff works. First, we're going to do the hardware mod to the Ace Pro, and then we'll get onto the software on the U1 to marry these two things together. All right, let's go. All right, now that we are at the desk here, let's take a closer look. So first, if we go to the browser over here and we go to the Snap Ace page on GitHub, When you scroll a little bit lower, this is what you're going to need to see here on this page. So if we zoom in, let me show you something. So we're looking at the bottom left-hand corner of the ACE right here. This is where the original plug is. And this original plug, you can actually cut it and literally solder on a USB cable on the other end. There's only 3 important wires here. There is the D-, D+, and ground. The other 3 can be ignored, including the 24 volt. You can actually make a huge issue for yourself if you run 24 volts through a USB cable into a USB cable wherever you plugged it in. So you don't want to do that. You actually literally only need D-, D+, and ground for your USB cable. Depending on what kind of USB cable that you cut, you'll be able to see exactly which wires connect to D-, plus, and ground. They're all color coded. It should be very easy. In fact, I'm going to leave a female connector that you can buy on Amazon. Nice and easy. They're color coded. It's brainless, and it fits really well over here onto the plug on this side. All right, so we'll follow along a little bit closer to how I did it, although I just cut an extension cable, and I'll show you that in a second. But this is the important part. This plug, and this plug is all you need. D-, D+, and ground. Like I said, you have some options here. You can use the original stock cable, splice into it, and modify the original one. Or if you want to keep that intact and use this with any Anycubic machine without modification to the cable, we'll add on a USB female plug, or even just a USB-A. It doesn't actually matter, as long as it has a D-, D+, and a ground. All right, just want to make that really, really clear. So here, let's go back to this view, and I can show you how we have mine set up. So as you can see right here, we have the original plugs, and right next to it we have a female USB-C. And what this essentially lets me do is, now if I take any regular old USB cable that's a data cable, I can plug in USB-C on this side, and now this can be plugged in to our Snapmaker or any single clipper machine that we want, and essentially be used as a management system. Or I can go ahead and use the stock plug. I decided to make it this way so that I can use this ACE unit for whatever. It doesn't have to just be completely married and stuck with the U1, or I might change my mind, whatever it might be. This is a little bit more reversible and more universal, and a little bit more useful in my personal experience here. All right, so let me go ahead and take this cover off so I can show you how we actually went ahead and made this, and you'll be able to do it as well. It is nice and easy. So check this out. So if I pull this out here, you'll actually start to see the secret sauce here. And this is literally an extension cable that I just dremelled a hole into, and have some hot glue on the back to hold things in place. And we made some room for this cable. I kept it long just in case I needed to do anything. But let's take out this actual plug. It's just 2 screws, and the actual plug has a little PCB board attached to it. And the PCB board is where all the magic happens here. So because this plug has pass-through pins, we can get onto the back of those pins. Let's just pull this all the way out right here and solder on those connections. So you will have this little black cable on the bottom holding this board in place. I'm just going to unplug it and pull this whole thing out so that you can see how it's made. It's actually just essentially a cable. So if I get you guys closer, you'll be able to see how I made it. So give this thing a second. There we go. So as you can see, we got our black, which is ground. We got white, which is D-, and in this cable's example, green is our D+. So you just use the back of this board where the plugs are to make sure you look at that pin out here on this screen right there, and you just go all the way through and you solder those cables. It's really easy. I'll have it up on the screen so you can have a better view of this board, not just from here, but you can see. Let's see, there it goes. Hold on, let this thing get closer so you can see. We got that middle bottom pin for ground. We have the upper middle one for D+, and then we have the corner top left here for D-. Should be easy. Any other cables you have in this USB-C cable, you just cut them off. You can actually hot glue this here if you wanted it to stay a little bit closer. But that's all it is. And then I needed a little bit more room here, so I quite literally took some snips and cut out this plastic. You can't see it. It's not in the way. If you have a much shorter cable than me, then you're not going to have that issue whatsoever. Nice and easy. So all you do is you plug this back in just like that, and then you got to get this cable in there. And like I said, I kept mine really long, which probably made it a little bit more difficult for myself than I had to. But we'll just get that all in there, and then all you do is just button this back up, cut yourself a hole right over here, and put this in there. And with the linked female connector that you'll see on the Amazon listing, that's going to be a much better and cleaner way to do this with a shorter cable with no nonsense. So that is the hardware portion of this. Let me go ahead and put this back together. Now that you know how to do that, let me grab an SD card or a USB drive, for a matter of fact. We're going to go ahead and get into software. Let's go. All right, so first things first, plug in your drive into your computer and make sure it is a FAT32 drive so that you can put files on here without any problems. Then go ahead and jump into the Snapmaker U1 extended firmware GitHub. I'll have a link down below. You can just jump through that link to make it easy. And on here, we need to download the correct bin file. The bin file is the firmware that we're going to be installing on the U1. So the way to get there is you go and look for releases on the right hand side. As you can see right here, 3 weeks ago, we're going to be clicking this, and this is where you're going to find all the changes that have been recently made and all the instructions that you need. They're very, very simple. What you want to do is you keep scrolling until you find assets, and then you choose which one of these firmwares you want to download. So there is just the PAX 12/13 upgrade, which is kind of the minimal modified version where it gives you just enough debugging and SSH access, which we need to turn on debug mode. Or you can go ahead and go with the extended version, which is what I went with. It gives you just a lot more ability if you wanted to use it. You don't have to, and I kind of like that. So I just always go ahead and do the extended version for this. But go ahead and download whichever one. You just click on one of these things, it's going to download, and you want to put this on the root of your SD card, which just means on the SD card without putting it in a folder or anything like that. Just put it on the main section. And what you want to do is head over to your printer and go ahead and find Settings, then About, then Firmware Version, and then Local Update. And go ahead and do that update. It's going to take a few minutes. Your printer might reboot a few times here and there, and then you should be good. And the cool thing about that is from there, all you need is to hook your machine up to Wi-Fi like you would normally, and then take your IP address and just put it into the browser, just like I did right here. So as you can see at the top here, we have the IP address of my machine, and we go to firmware-config. And what this does is this gives us all of the information about our current machine, as well as just a quick button to get to the current web interface. And in my case, it is, well, the machine's off right now, but in my case, it's Fluid. If you didn't want to use the Fluid front end, you can just go to the setting over here. Let's see, front end, and you can go ahead and install Mainsail. This gives you a bunch of settings that's very easy. The thing that we really need here, though, is this SSH access. We need to go ahead and enable this. Go ahead and hit enable. Go ahead and make sure that it does it. A pop-up will come up and show you that it went ahead and installed SSH access. Here's the other thing that I did is I turned on the internal camera to PAX 12. That way I could just use the Fluid front end with that. And that's all you really need here. One thing I do got to say is I went ahead and enabled the adaptive mesh, and I also tried to enable the TMC auto tune on my machine without doing anything else. The TMC auto tune made it so that I can't home. So I just advise you guys to not change anything in here except for the SSH access, and then once everything is running, you can come back to this thing and play around as you wish. It is obviously there for you to go ahead and mess with. But SSH access, make sure that's there, and then we'll go from there. So that's how you're doing this. Then we need to jump into the Snap Ace GitHub, and here we need to grab a couple of these files. We need the ACE CFG file, the ACE PY file, the extruder PY, and the filament underscore feed PY. These are the files that you need to grab. Also go ahead and grab the README file because the instructions are there in case you want to fall back and not just listen to me rant. You can just do it yourself. The way to grab these files from GitHub, there's a couple things. The easiest way is to go to the big green button that says code, go to local on the left if it's not selected, and just download the zip file. That's just the easiest way. Or if you just wanted to grab these files and nothing else, you can click into the file and then scroll to the top here and go to this download raw file button and grab them for yourself. It will eventually just look like this, a bunch of files in your browser here. Yep. Okay. So once you have these things, we got to follow the instructions in the README. So if we go ahead and open this, let's make it a little bigger. This will tell you exactly what to do. First thing we need to do is SSH into the machine to enable debug mode. So first things first, make sure your machine is on. I'm going to go ahead and turn mine on so I can show you how to get in here. And we got to give that a second to boot. While that's happening, SSH is usually done through things like terminal or command prompt on Windows. So I'm not sure exactly how to do it on Windows. There's plenty of directions and instructions on how to do it there. But when you are on a Mac, it is as easy as typing in SSH space root, the @ symbol, and then the IP address of your machine. And then basically this is saying that you want to SSH into this machine as root, and the password, if the machine is on already, let's see if it's on, there we go. The password is Snapmaker. So Snapmaker should get us in, and there we go, we are in, and that's how you know, is it says root at lava. Lava is what the machine is called internally there. So what we want to do is we want to actually type in touch. Here, I just copy and paste this, so this will be much easier, but it is essentially touch space /OEM / period debug, and when you hit enter, it's going to just literally do nothing, but that's actually a good thing. It'll turn debug mode, and what that'll do is you'll see a lot more information on the bottom of the screen on your machine, but it's going to help you not only figure things out, but it's also going to help this firmware connect with the Ace Pro. So that's all you need to do on the SSH side. Luckily, we don't have to jump through hoops there. You can just terminate this and close this. Here's the other tricky part. We need to put these files into various places on the U1. And I do this with an app called CyberDuck. There's lots of other ways to do this. You guys might have to look it up somewhere if you're running on a Windows machine on how to connect on. It looks like they're suggesting WinSCP as an application. But what this does is, once again, it lets you use that root access, IP address, and that password to get into the file system of your printer where you can put these files in. Let's see, can I make these a little larger? No, we can't make it larger. But all we're doing is we're following this exactly. This is telling me to take the ace.py and filament.py files, and you can keep the original ones, by the way. All you have to do is type in something like _stock or _OEM on the original files, and then put them into home, lava, clipper, clippy, extras. So if we go back here, all we have to do is look for here, let me move this down some so I can see this a little bit better. So we're looking for home, then we're looking for lava, then we're looking for clipper, then we're looking for clippy, then we're looking for extras, and in here we are putting in ace.py and filamentfeed.py. So if we look at mine here, I should have an ace. Let's see, here's my ace.py, that's just dropped in here, and the filament feed Here we go, and the filament feed .py is right here, and here is the stock one, so we can always revert. I just added an underscore stock before I drag those files in here. So you drag them in. This essentially acts like an internet folder. It lets you connect to the machine without having any kind of wires or anything like that. So that's the first step. Really, really easy. Then we're going here, and now we're taking the extruder py file. Once again, you're keeping the original extruder file. And we're going to Home, Lava, Clipper, Clippy, Kinematics. So if we go back a little bit here out of Extras, we're going to go into Kinematics. And this is where we're going to see our extruder PY that we just drop in, and the stock one that we renamed stock so it doesn't get overwritten, so that we have something to fall back on if we need to. All right, so for number 5 here, the ace.cfg file, we're going to put this into the config extended clipper using the web interface. So now that the machine is on, we can go ahead and shut this down, whichever app you're using, and we're going to grab this ace.cfg file. Let's go open Clipper up. So in order to get into Clipper, you just type in the IP address here. And on the left-hand side, if you're using Fluid, we're going to go to Configuration, then we're going to go to Extended and Clipper. And in here, we're going to hit the plus button, and we're going to upload that ace.cfg file right into here, and it will just pull itself up right here. So that should already be everything that you need to do to get your machine ready. And then what you need to do is you need to measure the PTFE tubes that are connected from the back of the ACE all the way up to your extruder. And the reason why is when you click into ace.cfg here and you scroll down a little bit, there's going to be a section here called tool change underscore feed underscore length. And this is the important part. What I did was I basically commented out the standard one, which was 600. I just put this little hash mark, and that makes it a comment. And I copied it down below so that just so I can fall back on something. And I measured my PTFE tube that I'm running. I'm actually keeping the stock PTFE tubes on here using a PTFE jointer and keeping the stock PTFE tubes on the U1 as well. So I'm just connecting them that way. But my total length was around 62 inches, and I landed at 1,400 or 1,490 millimeters of tubing. And there's this little formula, they tell you to minus about 50 or so, so that it doesn't go all the way inside and start pushing onto your extruder. It just kind of either touches, it gets pretty close. So like I said, I tuned this a little bit, and mine ended up being 1,490. So just measure your tube, that's where you put this, and all you need to do is go and put this into save and restart. This is as far as you need to get into the Clipper kind of knowledge. You just need to go in, read a couple things, make this little check, and like I said, everything is in the instructions on both of those places. So go ahead and hit save and restart. That's going to shut down Clipper for a few minutes and bring you back here. The best case scenario you want to do, or the best way to do this, is you want to reboot your machine. And actually, if we go back to your IP address and firmware dash config here, if you go to the bottom, there is a system reboot system button. Go ahead and hit this, and this will restart your machine all the way. It will restart the firmware on your Ace Pro and on the U1 as well. And now you should have a fully running machine on the new firmware, and you should have your hardware modified Ace that you can utilize for whatever Clipper machine you wanted, including the U1. All right, let me go ahead and put that back down. Let me hook up all the tubing, my USB-C cable, and I'll show you how easy it is to load filament up and how to use it from there. Let's go. By the way, just as a heads up, if you wanted to see where the drying action is, by the way, don't mind these errors, it's because I don't have the Ace hooked up. But if you wanted to use the drying function, you go right over here to the macros, and there is literally an Ace drying on and Ace drying off button, which you can just click and toggle between. And if you wanted to mess around with the temperature, go back to that ace.cfg file, and it's literally written right over here of what temperature that this thing runs at. So as you can see, the max is 70, and there's a macro right over here. So whenever you click that little macro, it says says Ace drying on, this is what it does. Here's your duration and here's your temperature. Oh, sorry, it was blocking. Right over here. So right underneath of it. So all you do is you can change these parameters. You can change how long you want it to go and what the temperature is. 70 is currently the maximum recommended. I think you can go higher, but you shouldn't. It's definitely recommended to keep it 70 because that's the safe limit of the actual heater that's installed in there. 55 is also pretty good if you're going to be mostly just doing PLA and TPU and or well, not TPU, but you can dry TPU in there and PETG. So 55 and your duration. If you wanted to modify this, just don't forget to always click save and restart. And in the case of rebooting this box, you can obviously manually shut it down after that and kick it back on. But going back to our firmware /config and going down to reboot system is just a sure way to go ahead and restart. All right, with that said, let's go install everything and show you what it's like to load this filament in. Let's go. Now that the firmware is installed, we have the hardware modified. We have all 4 tubes hooked up to the back of the machine. So each one of these goes to their corresponding tool head. So what you want to do is you want to make sure that the first spool goes to the first tool head. Then, of course, the second tool goes to the second tool head. You measured the distance from the top right here all the way down to the back of this. You put in that measurement just like in the tutorial. You should be all set. So right now I have my USB-C cable hooked up from there all the way to the back of the machine to here. So now they are communicating and all is well. You'll know that your firmware is working just fine because right on the bottom right here, you will go ahead and see the IP address of your machine, and that makes it really easy to type that in, by the way. And then, so here we go. I'm going to show you what it's like to get filament in here now. So what you do is you take your filament, you push it down, and you wait for it to start getting pulled. I like to help it along a little bit. Here, I'll close it so that it's easier for us to see. So this thing goes through a couple stages. It goes slowly, and then it kind of stops and goes much faster, and you should be able to start to see the filament going through the PTFE tubes out back there. And let's see if we can spot it in the camera. I know we should be able to see it right around here. There it goes, it's going up. And then now we should be able to see it through this awesome little window. And let's look for it in the PTFE tube up here. Here it comes. And we're almost in. And it should stop right there. All right, so the filament is now loaded. So what we do is on the machine, let's go ahead and pick our color. So first we'll do generic PLA. And this one is tan. They don't really have a tan. The color selection could definitely be better on this for sure. We're going to hit brown for now. I'm going to hit save, and then we're going to go to loading mode. Select that tool head. We're going to hit load. And you're going to see a bunch of messages too because of the debug mode. And it'll kind of guide you along what the machine is doing, which is nice to see. You kind of get a better idea of how it works and what it's doing. So right now it's going to home, and then it's going to pick up the second tool head. It's going to purge a little bit of that filament, and it's going to load it in, and that's where it's going to stay. And you'll see it appear on your screen right over here in just a few minutes. There you go. And we have a single little poop down there for the tan filament, and the screen just like it should. So it's success on the bottom there, and it says automatic loading success. So when we go back, there we go. All right, and just like that, you're all set up and ready to print. You can put in the rest of your filament. You can change them up, select whichever one's in the machine. You can change up your temperatures, dry them, whatever you want to do. It's pretty fantastic, and I just love the fact that we don't have them on the sides anymore. It really cleans this thing up. And there are printable covers, by the way, so dust covers for both here and for where that cable typically goes. That's where this unit actually right over here, where these things go, that's where the motor assists go on the side. So I just printed some caps. I'll include the links for this down below in the description as well if you want to clean yours up. But yeah, look how much better it looks. And most importantly, when you do end up with a top cover, whichever one, whether it's the official one or BQ or DIY solutions, this thing can go right on top of it, which is fantastic. Awesome. Alright guys, and with that, you should have a working, brand new combination of Snapmaker and Anycubic. Huge thank you to both teams that worked on these two projects. Guys, keep in mind, these are third-party firmwares. They're not made by either Anycubic or Snapmaker. This is a community modification with an open source community there. So huge thank you to both teams for working on this and making both of these products better, especially the Anycubic Ace Pro, considering you can now use this with that USB-C cable across so many more machines, including awesome machines like the Snapmaker U1. Another thing is, don't let soldering discourage you here. I know some people don't know how to solder or are not very good at it. I highly suggest you grab one of these pine sil soldering irons. This thing's amazing. It actually runs open source firmware on it, and it does cool things like when you set it down, it starts to cool down, and it can as soon as you pick it up, it powers back up, and you can power it using multiple different ways. It has really inexpensive tips. It's really affordable. I'll have links for this thing. This alone will help you do a job like this and make it really, really easy. While I'm up here close, here is an example of a print that I just pulled off the machine, and of course it came out perfect, and the tolerances are phenomenal, and it's just a fun little print. You know, kids like this type of stuff, right? But yeah, there it is. Everything's working. We're off to doing more prints. All right, guys, you know how YouTube works. Like and subscribe if you like this type of content. I have a lot more machines to finish reviewing. I'm on 90 now, and we're on the road to doing 100 different machines on the channel, so I'm pretty excited about that. If you guys want to support the channel, please go ahead and use my affiliate links down below. They'll take you to all the places that you need and all the links that you need to hit in order to do stuff like this. You can also become a Patreon or a YouTube member. You can also go to 3dprintsos.com there and grab yourself some cool merch like this and many more. If you're a different type of farmer, we even have options now. So there's lots going on. We have a Discord if you guys have questions or just want to talk about some things, reach out to me, etc., etc., etc. All right, guys, I'm Fitter from 3D Print SOS, and as always, I'll see you guys in the comments. Later.